So I guess we can start slowly. Welcome everyone to the last two sessions of today at Data Reuse Days. I'm going to quickly introduce you to our host for tonight, Andra Waagmeester, and then I will let him run the show. We will have two sessions, one after the other. First of all, we will talk a little bit about GeneWiki and how it used the Wikidata Integrator library to run the project. Then after a short break, there will be a bio hackathon, and I'm sure that Andra will explain a little bit more what it means exactly and how you can get involved. And yeah, this session will run for the rest of the evening, or at least evening here in Europe. So I hope that you enjoy the data reuse days so far. As usual, you can use the Etherpad to take notes and ask questions, especially since Andra mentioned that he will not necessarily be able to follow the Jitsi chat so much. So feel free to write down stuff here. And for the rest, enjoy.
Thank you, Leah. It's a great honor to talk about our project, GeneWiki and the Wikidata Integrator. As said, I will be recording this, and I unfortunately will not be seeing the chat. But if I'm totally fine with being interrupted, so please do if you want to dive into something else. But before I start with the presentation, I would like to use a segue. Before I continue, does everyone see my screen? You should see a Jupyter notebook now. Can you go back? Okay, it's not. Okay, I should have. And now, do you see?
Yes.
Okay,
yes.
Perfect. So this is I'm running I made a Jupyter notebook on the Jupyter server, which is called PAUSE, which is run by the Wikimedia Foundation. And it's really helpful in running Python scripts to do so. So what I'm doing here is, in the previous session, there was a question, how do you add a paper to Wikidata? And in this specific script, what it does, it installs the Wikidata Integrator into the Jupyter Notebook, which is a step that you need to do if you use Jupyter Notebooks. If you run it within your own IDE for Python, this step is not necessary after the initial installation. Then it installs the Wikidata Integrator and some helper functions. It installs some hiding of the passwords, and then a pandas notebook. So basically, when you run that will be installed. The next round is a username and a password. You log in with your Wikidata username, and once you have done that, you paste in the DOI of a paper. And provided the DOI is in Crossref, it will be added to Wikidata. So just before for this session, I went to PubMed and I selected one of the latest publications because I needed to be sure that the item is not in Wikidata yet, just for the sake of creating. And I added the DOI, logged in, and then ran a function that says get or create. So what this function does, it checks with Wikidata if the paper is already issued. If not, it creates it. So, and now if we go to Wikidata, and we type in the QID, and the paper has just been made. As in the different statements are being added, the statements of the title, the author name string, the publication date. So this was done all in one effort with all the proper references in place for this paper. So what we've been doing here is issuing one statement which will create a full item on Wikidata or report back if the DOI already exists in Wikidata. And you can actually then use that in batches. Although I'm usually not in favor of doing this in batches, but that's a different discussion. but that's possible. So you iterate over a set of DOIs, and then you can actually either get to the QIDs for the DOIs or initiate a paper. So that is in a nutshell what I wanted to talk about. It's about using bots to create Wikidata items. Now diving a bit in, I just gave the impression that it is super easy, which it is in this case. But what I didn't say is that in principle, what I did is the bot does a lot. So the bot decides that it's an instance of a scholarly article. The bot decides that this is the reference pattern that we want to use. So basically, it's a batch that runs on that. And that's where the complexity comes in. So, I will quickly make this a bit bigger. That's what I want to talk about now is actually, this is more the pipeline that we use. So imagine that this is the list of PubMed IDs. And then you want to check whether the PubMed IDs are already, the DOIs or the PubMed IDs are already in Wikidata. If that's not the case, add it. If it is the case, we want to check with an entity schema whether the item is conforming to the schema that I just mentioned. If that's not the case, the item is being locked for curation. So nothing happens after that. If it is okay, we update the existing Wikidata item with the novel information from a list of DOIs or anything else. And then again, check if the item adheres to the shape expression or the entity schema that we are interested in. If that's not the case, log for curation. If all these flags are green, eventually the item is edited. So this is the pipeline where the Wikidata Integrator is taking care of all the interactions. So it's about, I'm just going to skip this quickly. I just wanted to say that what we are doing is using Wikidata as a fair data platform, and today is the reusable. We're talking about reuse, but what we are trying to adhere is making our data findable, accessible, interoperable, and reusable. I recommend to watching at other fair data documents to do, but I just want to talk now about the GeneWiki project. The GeneWiki project started in 2008 as a project to create Wikipedia stubs on human genes. These stubs consisted of data imported from structured databases in a Wikipedia info box and crowdsourced knowledge on the genes. And one of the objectives was to extract additional knowledge through Wikipedia articles. So here you see one example. The big problem here is how do you extract the knowledge from a free text, which Wikipedia basically is. But Wikipedia also is a collection of 300 or more languages editions, which are maintained independently. So if you want to spread the knowledge about genes or anything, doing that requires, on all languages, requires extending to all the other language versions. And then you will run into various issues. For example, if you speak English and you're interested in malaria, you will see that you'll get the ICD-10 code, which is the International Classification for Diseases, being B50 and B54. However, if you go to the Dutch page or the Greek page, you will only get one identifier. Similarly, for the Dutch pub for numbers. So if you visit the Wikipedia page for Aruba, you will see different population numbers given the language edition of Wikipedia that you're going. This is a challenge to deal with. So. And when in 2012 Wikidata entered the equation, we were thrilled because now we were able to go from a Wikipedia article to the Wikidata for the Wikidata item, which looks a bit like this. I don't have to go into details, which leads to a the following anatomy, you have the header, you have the footer, and you have structured data using qualifiers and references, and also links to all the language versions. So with Wikidata, we are now able to add scientific knowledge to Wikidata, which then can trickle down to various Wikipedia versions and beyond other applications. And I'm going to skip this. So how do we do this? So whenever we in the GeneWiki project work on something, the first step is trying to identify what we are trying to put on online with Wikidata. This is typically going, well, here I use the pictures from a workshop that was where we tried to identify the schema for projects and grants. But often these discussions happen online, either in Zoom calls or document or shared documents. And then the main objective is to identify if we're talking about something that we want to align with Wikidata, what is the internal structure. At the end of this phase, what happens is a schema like this, nothing more than a whiteboard with some doodles that show some relationship. So at the end of such a session, we have a consensus, which is, as you see in this, either a whiteboard drawing or something in an online tool like PowerPoint or Draw.io. Well, you can pick your own drawing tool for diagrams. So once we have that, it's back to the drawing board, but now to identify to make those diagrams machine readable. So that's where we use the entity schemas. The idea is if we have a entity schema for the database or the concept that we want to add to Wikidata, we need machine readable descriptions of what we want in there. This to basically do the following. First, we want to know what is already known in Wikidata and how is that described. So you basically want a punch list to check if your view aligns with the view in Wikidata. And if that's not the case, how do you align them? Then you want to have documentation, what's the decision? And then you want to have what I just showed. You want to have the means to check your data before it's being ingested. I'm going to skip this, and it looks a bit like this. This is an entity schema for a human gene, and these are a selection of the human genes being described on Wikidata, and we are able to align the entity schema with the item, and in this case, all six item work as expected. Once we have the entity schema and we have the consensus of the community, meaning both on Wikidata side but also from the primary sources, it's where we step in with the data. And this means initially what we typically do is we manually add 1 to 10 Wikidata items and then see if we agree to that. And when that is the case, we write a bot. And then the bot updates one item to update the exact same items we did manually. Then, if there is no pushback from the community, we do 10. Same, we go to 100, go to 1,000, typically with an interval of 1 to 2 weeks in between. And then if there is not much discussion, we go full throttle and import the data from many sources and ontologies. And that happens in a platform that we call Jenkins. So and we use Wikidata Integrator, which is the main topic of this. So we use the Wikidata Integrator to align external data source, primary data sources with Wikidata. And we run those bots in a platform called Jenkins, which tells us when the bot ran last. So we regularly check what is on Wikidata, what is in the primary source to get something like this. The disease ontology is one of the ontologies we maintain. So the disease ontology has its own curation cycle, and Wikidata has its own curation cycle, and then the bot operators and the bioinformaticians monitor the exchange between the two. This leads to curation list, which is then presented to the disease ontology and upon which they can act. So input from Wikidata can trickle down to the disease ontology and back. So this talk, I'm just checking. Oh, I still have 5 to 10 minutes. Okay. So we are using the Wikidata Integrator for this. The Wikidata Integrator is a Python library, and it primarily caters Wikidata. But since Wikidata is a Wikibase, and Wikibase is an extension on MediaWiki, it is in principle possible to use the Wikidata Integrator to work with other Wikibases and the MediaWiki's API. But given hence the name, it really is about Wikidata. So there is also the Wikibase Integrator, which is a fork of the Wikidata Integrator and started the life on its own. And that one is specifically aimed at using Wikibase. I believe you can update Wikidata from that as well, but I haven't touched on that. And then there is PyWikibot, which is a more generic an application that basically works with the MediaWiki API. So that's a bit of the distinction between the three. With MediaWiki, you can update the Wikidata, Wikibase, and all the others, but that's more the generic. Wikidata Integrator works with an MIT license. It is online on GitHub, and you can install it using PyPy. And last but not least, it's a community project. So people are invited to join us on GitHub or submit pull requests, etc. So now some example notebooks. I already demonstrated the DOI helper function in the beginning of my talk, but I created a set of, I will just open them and hopefully they opened up. So this is an empty notebook which just showed a really minimal effort to create a Wikidata bot. So again, I already mentioned the pip install Wikidata Integrator, and I already mentioned the libraries that need to be installed, the login, and this is basically what happens. So by going to what you do is you create a list of statements. And therefore, each statement, there will be there is a specific function. So you have the Wikidata ID, the wiki string. So for every data type, there is a specific. And I initially tried to put this in here, but it looked quite messy. So here I really refer to the item. And I will show a real example where this shows. But basically, this is the workflow. You log in, you select all the items, you add all the statements to a variable called data, and then you let the Wikidata item add that to Wikidata. And then once you're okay, you can do some checks and balances before you submit to the API. But what it will create is the JSON object that is being submitted to the API, which happens in this line. And this is the library that I will share on Pause. You can use it on the Jupyter server of Wikimedia. And I also have a clone on Google Colab, which you can use. And then finally, this is an actual bot. So this is a bot that I developed to add terms from OBO ontologies. There is a little side note here. So we are doing the disease ontology, but also other ontologies. You can directly put full ontologies as the disease ontology or other OBO ontologies, provided the license is CC0, where a lot of the OBO ontologies are not. So there you have to limit yourself to only the identifier mapping. So no instance of and no subclass of information. So that is what this bot does. So going over it again, first I installed a Wikidata Integrator. Then I set some libraries, log into Wikidata, so maintain the login key as a variable. Then create a set of references. So here you actually see what I just mentioned. So with this function, I'm creating a single record into Wikidata, which works as follows. I say there is a statement stated in statement. The stated in statement is a OBO ID item, which has a property stated in 248 and is a reference. Then I fetch the date to make a timestamp and put in the ID, and in the end of return the reference that will be used as a reference in the Wikidata item we're interested in. This stated in is this is then used. So then I go to the Wikidata Sparkle endpoint, the Wikidata query surface, to get all the ontologies that are described in Wikidata. And I need that information because I need to know, well, so for the OBO is a family of ontologies, which has much more than the one listed in here. But currently, these ontologies are being described in Wikidata, and I needed this information because I need a short name. So, so the first thing that I wanted to do in this bot, I want to align a term from the pathway ontology, which has an identifier PW and then this number, and which is the pathway ontology is here. And then we'll get the formatter URL's information, and we'll get the property number. And basically the property number is important. So then from the OBO ID, I create the OBO URI, which I need to, which I will add, which is this one. So I replace the colon to the underscore. I fetch the full term. So the ontology term, I fetch the primary data. And then I start building for the one, let's skip a lot of the things. So then I start building the item engine. So first I will create a reference, which is what I initially, before I gave the OBO ID, and it will create the reference as has been described in the function. Then I create a list of statements. And here we start. So in this item that we want to update, we want to have a statement that has the property Wikidata ID, which I fetched from Wikidata. We want these references, and we want this value. And we also want to do the exact match. So the exact match being the URI, and we build up. Once we have built up this set of statements, the statements will be added to an object item. If the item doesn't have a label, the label and the description is set, and then the item is written to Wikidata. And once that is the case, I can go back to that item, and you will see that this item has been created. It's an item that gets antigen processing and presentation pathway. It has an exact match, and it has an ontology ID. You're missing here statement and subclub information because the CC BY license of that ontology prevents me or a bot to add that to Wikidata. So that this either has to be added by a person, or the legal scholars need to argue that you can indeed do those creative statements into Wikidata. Okay, going back to my talk, I think I have 1 minute. So here are the notebooks. And then the final slide is, this is, let me increase that a bit. This is, we have the Wikidata Integrator. We have a platform called Jenkins, which regularly run the bots into Wikidata. And this creates a landscape which is documented in this paper, that monitors these objects from the life sciences into Wikidata. And that is it in short. Let's see, I think we have 5 minutes.
Andra, do you want me to read out questions from the Etherpad for you?
Oh, yes, or I have it here. Maybe I can quickly have a look, otherwise... okay, no, I can see it. I think I can...
The questions are further down. Yep, there.
Okay. Have evidence of using over pause for, yes and no. So what I really miss in pause is collaborative work. So what I've showed before is when you work with pause, you cannot share the notebook with others. You have to make a public link where you need to be super cautious, because once you have, if you have, for example, password information and user information, you make it public, you're sharing that information, which is why I use this getPass library to hide it. So that works super easy with Colab. Both with Colab and Pause, I had to stop using both because at some point, Colab and Pause were behind with the Python version. But since they have been updated to Python 3.8, I can use both again. There is one super benefit about using Pause, and this comes with timeouts. If you have a Spark query that times out on your computer, you might want to rerun the query on Pause. There is also a Sparkle notebook on kernel on that version. I don't know why, but I suspect it's built on the same infrastructure as all the other Wikidata infrastructures. So sometimes whenever I run into timeouts on my own computer, I had to pause and then it works. But in principle, yeah, the main frustration I have with pause is that I cannot. So for those of you who don't know, Google Colab is basically a Jupyter notebook that works like Google Docs. So you can collectively work on a Jupyter notebook, and so that really helps. Although I must admit that there is some strange situation. As you have seen, I used blocks. So for example, here I have this block, and then I run it. But sometimes when you run the script together, you can run in strange situations, because although you share the notebook, you don't share the state of the library. But there the solution is basically make a copy and run it on your own. But in terms of programming, this helps, but that's a minor thing. And okay, other questions? How do you monitor the actions of your bot to verify that you're correctly working as expected? And so we have the Jupyter notebook. So we have this framework that I mentioned earlier. So whenever we start with a new bot, there is a very slow pipeline, which is the slide which I demonstrated in the slides. Here we go into semantic modeling, we write the entity schema, and then and we use the entity schema to verify that it's going well. And then we manually create an item or 2, 3, 5, 10, depending on the need. And then the first step is to see if the bot replicates the exact same behavior as the manual thing. If that's the case, we push it to 100 and 1000, etc. And that's one thing. And there is, of course, there is a Jupyter notebook, the Jenkins server. So I can maybe briefly show that here. Jenkins lab, so there is actually one bot running now, and I can now go to the console output and see there is an issue that I need to look at, that this is nice. And also, if one of those checks and balances don't work, nothing happens, and it is being logged in. Let's check. Oh, I'm not logged in. So we have curation reports that we monitor. I think that's, if there are no, that's this. I hope that answered the question. Otherwise, so let me see. Do you have documentation to the community process for designing about the check structure somewhere? It could be used as a good practice example. So there is ours, but do you have a documentation of the community process of deciding about the check structure somewhere? So this is the, if we go to Wikidata, This is the one for the genes, E37. And so I have the entity schema. I know, of course, I know this. So this has been described as it imports some entity schemas, but basically it reads. We try to document it by using command lines, and then here you can actually see. So it's a gene, so it's an instance of a gene. This is a pattern I really like, because what we say here is both the genomic start and the genomic end are optional, but if one exists, you want to get the other. So here is what we do, what we document, how we document our decisions. Let me see if I go back. In terms of the check structure, no, there is. I wouldn't call it a community process. The community process is actually free. So you can usually, as I said, we don't use checks to decide on the document. We use checks once there is agreement, and this agreement depends on the community, whether they want to use a Wikidata text, a Google Doc, a diagram, etc. And then in terms of checks, I can point to tutorials and documentation about checks. Yes, I meant for no. There is really, and I think that's crucial, because you don't want to talk about the syntax or the semantics. You really want to extract the meaning. So there is not really a guideline, and we try to. I usually try to align with the workflows being used in that community. So basically, yeah, well, it depends. There is a general workflow, which is as I said, maybe I should write it down. Pick the canonical example. So if we're talking about boats or shipwrecks, select 5 shipwrecks that you consider as a community to be the best. Then go to the whiteboard and start drawing those statements as if they are item, property, value statements, and try to make this semantic map. And then really try to align it with your own community standards. And when that's the case, then we take up, and that's when the checks editors come in and make it into the checks. You mentioned the problem of CC bias. Okay, so this is going to be a strong opinion. So Wikidata is CC0. And which means that nothing of other than CC0 can go in except for some facts. So specifically in the case of the ontologies, that can be problematic, because when are you allowed to add ontological statements to Wikidata and when not? So my understanding, with big disclaimer, I'm not a lawyer, is that you are not allowed to use any ontology in Wikidata if it's not CC0. As I mentioned, the identifiers and the mapping, yes, but creative statements such as subclass of or instance of, which can be considered the creative process of an ontology, cannot be hosted in Wikidata. But I have been bold on this, and some folks tell me that I worry too much. Others says that it's indeed problematic. You should not use non-CC0 ontologies in Wikidata. Yes, there is a repository online. I will share this afterwards because I need to dig it up. Yes, yeah. As well, I will share the slides to immediately after this call and add it to this Etherpad. And having said that, I think I need to end now, because in 5 minutes we are going to talk about subsetting. So I would say either go for a coffee, or I will try to see if there are any other questions, but please share your questions there, and then I'm going for a break for 5 minutes, and then I hope to see you back in 5 minutes when we're starting to talk about how to get data back from Wikidata that you put into Wikidata. Oh yes, and good point. I will put it on comments.